In the 1930s, scientists deduced that stars were like natural factories formed of hydrogen and some helium, the two simplest and by far the most common elements in the universe. At their cores, where the temperature and the pressure are greatest, stars convert the simplest atoms of all into everything else: carbon, oxygen, nitrogen, etc., giving off light and heat in the process. But there was still a question as to where all the hydrogen and helium had come from in the first place. Spectroscopy had told us that the great gas clouds from which the stars formed consisted of 75% hydrogen and 25% helium. But where these gases came from was still a mystery. But then, in 1948, George Gamow carried out the first detailed calculations using the new understanding of nuclear fusion and asked if the universe had a beginning. If all the energy in the universe was once crammed into one place, what would happen? He calculated that it would have been too hot for atoms to exist, and that all that could have existed at such temperatures was raw energy. But he knew that after the beginning, the universe would cool and energy would become matter, as per Einstein's E equals mc squared. But what matter would it become? He found that such conditions would result in a universe filled with 75% hydrogen and 25% helium. Now, if you think that that is a coincidence, if you think those calculations haven't been checked by generations of physicists using increasingly more powerful computers with better observations, then you are fooling yourself. But Gamow went further than that. He realized that by no means all the energy could have been converted into matter, so he asked the question, what will happen to the excess energy from the fireball after 10 or so billion years? And he calculated that the light from the birth of the universe would have been stretched, its wavelength lengthened to way below that of visible light into the microwave region. Further, he calculated that the temperature to which the 10 or so billion degrees at the beginning must have cooled, and he came up with a figure of minus 268 degrees, 5 degrees above absolute zero. And he said that the microwave radiation from the initial expansion should still be there, waiting to be detected when instruments one day became sensitive enough to detect it. If the Big Bang really did happen, the background racial radiation had to be there. In 1965, Arno Penzias and Robert Wilson, while trying to discover the source of some unexplained radio interference that seemed to come from all directions, accidentally stumbled upon the cosmic microwave background radiation, as predicted by Gamow 20 years earlier. They were awarded the Nobel Prize. In 1990, the COBE satellite went up to take a closer look at the microwave radiation to give us an accurate measurement on its temperature and wavelength. The wavelength is exactly what would be expected if the Big Bang was true, and the temperature was found to be 270 degrees, only 2 degrees lower than Gamow's prediction, which, when one takes into account the inferior measurements available to Gamow at the time in 1948, it reveals he was pretty much spot on. There are a few other things that we should see if the Big Bang is accurate. We should expect that the universe has changed over time, and it has. The Hubble telescope has been able to see 12 billion years back into the past and take a picture of the most distant and therefore the oldest galaxies ever seen. Spiral galaxies of today have had the time to settle down and become highly ordered. Older galaxies seen by the Space Telescope are not fully formed, indicating that the galaxies of today have evolved from disordered states. So in conclusion, to replace the Big Bang theory, you must have a better theory, one that explains in detail the wavelength, the temperatures, and the existence of the background radiation temperature, the creation of matter in the ratios and abundances found by spectroscopy, the apparent ages of white dwarfs, the immature shapes of distant galaxies, not to mention the fact that the universe is still expanding. All of the evidence says yes, and until you have a better theory, I'll follow where the evidence leads me.